Hi, it's me, Tim Dodd, the Everyday Astronaut. Welcome to an exciting launch here tonight because we're going to see Rocket Lab attempt to recover their Electron booster. And I always like seeing any kind of stuff like this. Ooh, and actually their stream is starting to pop up. So this is good news. Means they're on track. They wouldn't have started the stream if they weren't going to be doing that. So that's great news. I love seeing that. So as always, guys, whenever we're about to, cover rocket launch and you guys have the same questions, where is this launching from? Is it landing? What's it carrying? Etc., etc. We always have you covered here at Everyday Astronaut. So that being said, let's head on over to everydayastronaut.com. We can click on the upcoming launches tab at the top and we can go through our pre-launch preview. So this is for the mission Baby Come Back. I wonder why they named it that. I have no idea. I have no idea. Do you guys have any idea? Obviously, it's because the booster's returning and they're going to be trying to... This one's a little bit new and improved. We'll talk about that a little bit more in a second. And we'll talk about how they're planning to recover and what changed. But for now, let's go through all the facts for you guys. As you can see, the launch is going to be happening in about 22 minutes. That's at 1:27 UTC or 13:27 New Zealand Standard Time. The mission name is, of course, again, Baby Come Back. And it is a rideshare mission. The launch provider, this is Rocket Lab. Obviously, hopefully you saw the title and stuff. The customer who's paying for this. This is a cool one that says NASA Payloads, Spaceflight Laboratory, or SFL, and Spire Global. The rocket is the only one that is currently flying from Rocket Lab, and that is the Electron rocket. Their mighty, mighty little rocket, which is just amazing. And then let's see here. Then there's the launch location. This is taking off from Launch Complex 1B, so the second pad down there at the Māhia Peninsula in New Zealand. The payload mass for this, only 86 kilograms, and that's the beauty of small sats and small rocket launches. That's a very lightweight payload, well within the capabilities of the Electron rocket. The Electron can launch a little over 300 kilograms these days, depending on where it's going, but this is going out to a 1,000 kilometer sun-synchronous orbit, so that's actually a pretty high altitude sun-synchronous orbit, so it probably will take a lot of the energy of the Electron rocket to be able to hit that orbit. So it's a higher orbit and it's a sun-synchronous orbit, so it's going to take more energy to get there than a standard, in their case, kind of a low inclination orbit would be, I think they're like 38 degrees or something straight east would be the maximum they can launch. This is going to take a payload hit because it's not getting the full rotation of the Earth. Sorry, long tangent. But will they be attempting to recover the first stage? Yes. This is one of the only other companies that we can, say that they're working on recovering rockets besides when we stream SpaceX stuff. They are attempting to recover the first stage. Where will they be attempting? Now, here's the thing. They have given up on the helicopter recovery, basically realizing like, hey, it's not actually worth it for whatever reason. They had a couple tries with decent results, actually physically catching it once and then having to release it, catch and release. They had okay success, but I think at the end of the day, the boosters were actually looking so good when they did splash down. They basically just said, what if we just kind of tweak these a little bit more just to be a little bit better at splashing down, right? That's kind of the theory is, if we just make these things more gooder at splashing down, then then we can just do that, And I think that's probably the right way to be doing this. At least they think that's the right way to do that, and I wouldn't doubt them. So that's what we're going to be seeing is them splashing it down and then recovering it with an updated recovery method from their ship. Now, will they be attempting to recover fairings? Nope, that's still something that only SpaceX, to my knowledge, is actively doing. Ooh, and their stream is actually starting. So give me a second. We will pull that up here in a little bit because I do want to listen. I think they're going to give us some updates. This is the 6th Rocket Lab launch of this year, the 4th launch from Launch Complex 1B, the 39th Electron launch ever, and the 105th orbital launch attempt throughout the world. Crazy. Go ahead and read through the rest of this article here if you guys want. It's a great article telling you especially about the NASA's Starling. Don't get it confused with Starling program. It's a really cool swarm concept. And a few other cool things here. But I'm going to pull up their stuff here so that we can listen in and learn together. And there's a lot of people I got to thank too. So I'll be getting in there soon. But first off, real quick, before we get out of here, say thank you to Maria for writing this article. Everyone in chat, say thank you. We're going to hop on over and listen in, see what we learn. All right, let's do this.
Hello and welcome to the live webcast of our 39th Electron mission called Baby Come Back. It is now 1:07 on the 18th of July, New Zealand Standard Time, and we are at T-minus 18 minutes to today's Electron launch. I'm Imogen Ray.
And I'm James Rattray, and we're here at Rocket Lab's Mission Control Centre to guide you through today's journey to space, a rideshare mission for 3 customers from Pad B at Launch Complex 1.
You might have noticed the red paint scheme on Electron today. That's right, on top of the primary mission to deploy customers' satellites to orbit, we will attempt to recover Electron's booster from the ocean after it returns to Earth under a parachute. Launch preparations are going well and Electron is vertical and ready on Pad B. We are scheduled to launch today at 13:27 local time or 1:27 UTC. For those watching in the US, that is 21:27 Eastern or 18:27 Pacific. We have multiple backup opportunities throughout the remainder of this 2-week window in case we're unable to launch today. Those launch timings remain the same for every day of the window should we need to reschedule for any reason. The good news, though, is that all operations are currently running smoothly and we're continuing the pre-launch procedures as we approach T0. We've got a ton of information to share about today's mission, so let's get started.
Absolutely. Baby Come Back will launch a total of 7 satellites to a sun-synchronous orbit for 3 customers. Riding on today's mission is a spacecraft for spaceflight laboratories, 4 CubeSats for NASA, and 2 satellites for Spire Global. Let's get into a bit more detail about these payloads in order of deployment. First off the payload plate will be the 4 CubeSats from NASA as part of the agency's Starlink mission, designed to test technologies to enable future swarm missions. Spacecraft swarms refer to multiple spacecraft autonomously coordinating their activities on orbit as one. Here's more from NASA.
Groups of self-coordinating spacecraft.
Okay, unfortunately, half the time these videos have, as those of you that watch these often, they might have copyrighted music, and then we get a copyright strike, and it can even get so bad sometimes it'll shut our stream down. So that being said, we can learn more about this later, but they're talking about the swarm of satellites, how they're able to autonomously control themselves, which is a really cool concept. Let's see here. I wanted to just kind of read through a few of your guys' comments while we can, and I'll get through as many of them as I can as well. This one comes from Merrick Stern. Thank you so much for your channel. I started not knowing the difference in the Falcon 1 and Starship. Now I know nearly everything about rocket science. Thank you so much. That's what I love to hear. Of course, those of you that happen to be tuning in now, I assume most of you are probably longtime viewers. Raise your hand if you're subscribed and you've been here for a long time. Let's see it. But I'm guessing, there's always a few new people that trickle in. The idea of Everyday Astronaut is to get you guys excited about spaceflight and rocket science and astronomy, all space sciences basically, and anything that's pushing humanity forward into the stars. And there's a lot of things to be excited about this day and age, with more rockets launching than ever before, with rockets being reused and recovered, and people exploring more than they've explored before, with humans returning to the moon for the first time in 50 years. So welcome, and I hope you guys learned something along with me as well.
And joining NASA's Starlink spacecraft are a pair of satellites for Spire Global. Spire's 2 3U satellites are carrying Global Navigation Satellite System radio occultation payloads to replenish its fully deployed constellation of more than 100 multipurpose satellites. Spire's satellites observe the Earth in real time using radio frequency technology. The data acquired by their GNSS RO payloads provide global weather intelligence that can be assimilated into weather models to improve the accuracy of forecasts. Spire is the largest producer of GNSS RO weather data, collecting over 20,000 radio occultation profiles every single day. Fun fact, Spire satellites flew on our very first commercial Electron launch to orbit all the way back in 2018 on the still testing mission. So it's great to have Spire back on board Electron today, all these years later. Let's learn a little bit more about radio occultation from Spire.
Okay, and again, to avoid copyright strikes, I'll answer a few more questions here. And again, remember guys, you don't have to super chat or anything. We just pull up good questions. So if you have a good question, we will answer it. And this is a great one from Definitive. Is this a SpaceX style powered return to land or drone, or a parachute style return? So they use a parachute, and in fact, they actually modified, and hopefully they talk about that. They modified their parachute a little bit on today's mission, since they are no longer trying to aero capture it, and they're no longer using a helicopter. They don't care so much about how much time it spends gliding and having any kind of, long air hang time so they can grab it easier. They're more just worried about making it lightweight and splash down softly. So they've modified it and made it so it's just, just more, again, gooder, sorry, at that. Hopefully we see that system work really well today and have a nice, safe, smooth splashdown. Let's see, this is from John Monroe. I'm in Christchurch and want to know of a good tool to pinpoint the location of the rocket as it swings on by, something like flight radar, but for a rocket rather than planes. Yes, you need to look up flightclub.io. That's flight, FLIGHT club.io. Declan plots out the trajectories of rockets, and you can actually see in real time what it's going to look like and where it'll be in the sky.
Our vertical integration philosophy into action today. Both NASA and Spire are using our in-house designed and built Maxwell satellite dispensers to deploy their payloads from Electron's kick stage on today's mission.
Finally, we have the LEO 3 demonstration microsatellite built by Spaceflight Laboratory for Telesat. The LEO 3 satellite will provide continuity for customer and vendor testing campaigns following the decommissioning of Telesat's Phase 1 LEO satellite. Once deployed to orbit, LEO 3 will operate under an existing ITU network filing for Telesat's Lightspeed, the company's enterprise LEO constellation.
We're looking forward to hearing more about our customers achieving their science missions over the next few months. But for now, let's check in on the clock as we are at T-minus 12 minutes and 19 seconds, which means it's time to listen in to our launch director for the final go, no-go poll as we proceed through the final minutes of the countdown. Each operator will now check in from their stations to confirm all systems are go for launch.
I love a good go, no-go poll.
All operators, this is the LD on mission, proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM.
MM is go.
Recovery.
Recovery is go.
LD sup.
LD sup is go.
That completes the go, no-go sequence. We are T-minus 11 minutes, 21 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
So if we hear hold, it'll they stop the terminal count and maybe reset it, or maybe it means a scrub for the day, but hopefully
Good comms there from
mission.
Launch Director Joseph Carpico and the team in Mission Control, confirming that we'll be proceeding with the rest of today's countdown and moving forward to liftoff in approximately 10 minutes and 45 seconds.
Cool. We'd love to hear it. Now, I did want to mention, let's see if we can fit this in. It's a good question from Musical Wolves. Let's see, just in case they don't count, I'm gonna start saying this, and of course I don't want to interrupt them. So here we go. This is from Musical Wolves, a good friend. Has anything been done to the engine or body of the rocket to protect it from the salt water at splashdown? Yes, they actually tweeted earlier yesterday or today that they've just made some tweaks, and I think Peter Beck even did a little snippet with somebody, just saying that they have actually sealed the rocket up a little bit better to be a little bit more waterproof.
GC on mission.
Go ahead, GC.
Stage 1 igniter pressures verified, hydraulic pressures verified.
Roger, thank you, sir.
As always, today's primary mission is deploying our customers' satellites to orbit. But as we hinted at before, we're also very excited to have a secondary objective today, to recover Electron's first stage as part of our reusability program. After completing multiple marine recoveries and perfecting the process, we are going all in on this method, which involves gently splashing Electron down in the ocean under a parachute and then extracting it onto our recovery vessel for transport to our factory for refurbishment and eventual reflight.
The Electron vehicle today features new innovations developed as a result of the lessons learned on previous recovery missions. This one features improved sealing solutions within the interstage and power pack, and some internal components on the first stage Rutherford have been adapted for improved saltwater resilience. If you keep a close eye on stage separation about 2.5 minutes into flight, you should be able to catch a glimpse of the sealing as the first and second stages separate, revealing the inside of the interstage.
Let's hear a little bit more about the progress our recovery team has made on making Electron the world's first reusable small launch vehicle.
Okay, so I'm going to duck it out when there's music, just so we don't get copyright strikes. And let's see if... Okay, here we go.
You can see behind me, it's red for recovery. We've developed from going from aerial capture, and we've recently pivoted to marine retrieval. This gave us a few extra challenges, but with the engineers that we have at Rocket Lab, we were able to introduce some simple sealing solutions, which will enable reusability. Over the last year, we've been working pretty hard in the background to re-qualify, assess, inspect the hardware from previous returned rockets. And my confidence level in relaunch is 100%. I wouldn't be doing this if I didn't believe in the program and what we're about to do. We're in a very fortunate position to have hardware that is easy to be dispositioned for reuse, and we can do this on multiple cycles. We've been working in the back.
Is that like a little... Does anyone know what that was? Is that a sonar, like some kind of radar penetration or sound penetration or something that could look at the... how things are, to look for any kind of cracks in the structure or anything. I've never seen that exact tool before, but I'm sure someone out there probably knows exactly what that is and probably uses it every day or something. So if anyone knows what that is, let me know. That was really cool. Here, let's keep listening.
With new solutions to get the vehicle back to the factory for refurb.
Ultrasonic testers, what everyone... Non-destructive ultras... Look at you guys. I love this. This is what I love about... Sonar, yeah, you're right. That wouldn't be very... Hey, I mean, if there's a baby inside there, maybe it'd make sense, but thank you, guys.
Over a series of rockets, we're introducing minor changes for Flight 39. 41 will have a few more. 45 will be our golden child, which is going to have all our sealing changes. And this is going to enable us to disposition the vehicle accurately for reuse and create that historic information that we need to be able to disposition the vehicle for its life cycles and eventually turn the whole production into more of a fleet management style production, and overall putting the company in a better position to launch more frequent.
That's so cool. So yeah, they've made some tweaks. You can tell the interstage was all like black now, which is really cool.
Is marine retrieval. We'll be following a similar process to our previous recovery attempts, using a capture apparatus that you can see there on your screen to lift Electron on board the recovery vessel. Here's what we can expect from today's recovery attempt.
Around 2.5 minutes after liftoff, Electron's first and second stages will separate as normal, and Electron's second stage will continue into orbit, where the kick stage will separate and deploy the satellites. Back on the first stage, though, with all 9 Rutherford engines shut down, a reaction control system will reorient the stage to place it on the correct angle of attack to enable it to survive the brutal re-entry environment, what we call the wall, during its descent back to Earth.
At around 7 minutes after liftoff, a drogue parachute will be deployed to increase drag and to stabilise the first stage as it descends. In the final kilometres of descent, a large main parachute will be deployed to further slow the stage and enable a controlled splashdown. Once the stage is aboard the recovery vessel, our team will then begin the flushing and preservation steps to remove salt water, prevent corrosion, and secure the stage for the return voyage to our production complex.
Today's mission is another major step forward in our plan to evolve Electron into a reusable rocket, and we're taking all of this experience into the development of our medium-lift rocket, Neutron, as well.
All right, it's now T-minus 5 minutes before liftoff, but before we get to that, let's take a quick look back at our most recent launch, one you might not have watched yet. Last month, we launched our first suborbital mission using HASTE, our hypersonic accelerator suborbital testbed Electron vehicle. This mission, called Scout's Arrow, lifted off from Launch Complex 2 and was a large-scale test in partnership with Leidos for the Mark TB program, which is designed to increase the speed of testing for commercially available hypersonic systems. Let's check out that launch.
Sweet. Again, for sure this... Oh, maybe it doesn't. They're hypersonic, so we don't know a ton about them actually, because most of the time it's for the Department of Defense. And so basically, they launch it at a shallow profile where they can reach hypersonic speed, so beyond supersonic. And there's a lot of things a lot of research being done in this world. We actually I think I woke up this morning seeing, or maybe it was yesterday, that China even showed some footage of a hypersonic test, which is really unusual to be kind of showing that kind of stuff off. But yeah, you can see it's pretty much a normal Electron rocket, but they just, instead of aiming, to get into space and then to get into orbit, they basically are just trying to stay up in the upper atmosphere and reach hypersonic speeds using rocket propulsion to be able to test material sciences and who knows all what sorts of things. And there you go. That's what that is about.
Scout Arrow was our third mission from LC2 in Virginia this year, following our first 2 launches in January and then in March, demonstrating an impressive launch cadence from our team, as well as tremendous continued support from NASA Wallops and the Virginia Spaceport Authority.
At T-minus 3 minutes and 4 seconds away from launch, Electron remains in good health and the satellites inside the fairing are good to go. The weather is trending green and the path to orbit is looking clear from Launch Complex 1 at T0. Soon we'll hear the call that LOX top-off is complete on Electron, telling us that the rocket is fully fueled for launch. When the rocket has completed fueling, Electron's internal computers, take over the countdown to run the vehicle autonomously at T-minus 2 minutes. Of course, you know the drill. From T-minus 10 seconds, we'll hear the launch director, Joseph Carpico, count down the final seconds before Electron's 9 Rutherford engines ignite 3 seconds before liftoff.
We're going to hand over now to Mission Control to follow along for those final moments before liftoff.
I did want to point out Tex? I have no idea how to say that. Have they been able to successfully pull this off in the past, or will this be the first time? So they've actually done multiple successful splashdowns. A few of them were attempted air recovery using the helicopter, and they ended up just eventually splashing down. But they've also just splashed them down. I think this is probably the 5th or the 6th. Maybe we actually had in our pre-launch preview, and I don't remember already.
The vehicle is on internal power.
But yes, they have very successfully done it, but they're trying to make the rocket more and more resilient and I guess prepared for water recovery, and hopefully make progress towards actually reusing eventually an entire rocket. This could be the first one. If this comes back and looks great, this could be the first one to actually be reflown, but
LOX load is complete. System is in recirculation.
It's an iterative step.
AFTS is green, enabled for flight.
Flight terminations go. So of course, I feel like I always need to say that there's you will see kind of condensation floating around. It's not smoke. That is actually just from evaporators and different things that are really, really, really cold. So there's actually liquid oxygen on the vehicle, which is minus 183 degrees or whatever Celsius. Very cold. So that tank, you can actually see.
Stage 1, Stage 2, press for flight.
It normally looks silver from the paint on the carbon fiber.
High flow engine purge enabled.
I better just shut up. But what's white is from where the liquid oxygen is being held. So it's really cold. And that's literally ice built up on it. Okay, I'll be quiet now. It's time to go.
T-minus 20 seconds and counting.
Oh, pointy end is up, flaming end is down. Thank you, guys.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Liftoff.
Liftoff.
The vehicle has cleared the pad, safing launch pad.
There go the cows running and sheep running.
Stage 1 propulsion nominal.
That's likely water. actually trapped
And that's
behind the
Liftoff.
lens.
Our 39th Electron
There we
launch
go.
vehicle is in the sky for this mission and progressing well on its way to sun-synchronous orbit.
The first major milestone in flight is max Q, or maximum aerodynamic pressure. Just ahead of 1 minute 20 seconds, Electron will push through the highest amount of aerodynamic stress it experiences.
Beautiful.
Approaching max Q. Cleared max Q.
And with word from Mission Control, we can confirm that Electron has successfully passed through max Q and is continuing on its southeastern trajectory off the coast of New Zealand. The first stage's Rutherford engines are firing nominally as we come up to the next series of events in the vehicle's launch profile, starting with main engine cutoff, or MECO.
Electron will go through a clean separation of the first and second stages before the single Rutherford engine on the second stage
Guidance
fires
nominal.
up and
Altitude
takes
is
the vehicle
28
satellites
kilometers,
the rest
speed
of the
is
way into orbit.
1,022
We should
meters
see
per
those
second.
actions on screen and hear the call-outs from Mission
AUS
Control
station.
operators shortly.
I should point out this kind of silvery.
Operation then marks the first step in today's
Stage one
recovery
propulsion
mission as
holding
well,
nominal.
as that
Stand by
first
for
stage
MECO in
reaches
roughly 30
apogee before
seconds.
making its journey back down to Earth.
I should point out that silver thing you guys see kind of on the left-hand side of the where the red line is. That's
15
actually
seconds to staging.
Entered burnout detect mode.
that's a cold gas thruster to help orient the booster to maintain proper orientation as it falls back through the atmosphere. There's going to be
MECO confirmed.
Stage separation successful.
Guidance nominal. Altitude is 77 kilometers. Speed is 2,082 meters per second.
Stage 2 ignition confirmed.
And there we go. We have confirmed a successful transition from the first to second stages of Electron's flight, with MECO, stage separation, and second stage engine start all nominal. You can now see the orange glow of the space-optimised Rutherford engine as it carries
Stage 2
on into
propulsion
space.
holding nominal.
The payload fairing, the protective shell at the top of Electron, protects the satellites, but since we've cleared the lower atmosphere, they don't need this protection anymore. Let's keep an eye out for when the payload fairing, and there it goes, to get rid of all that dead weight, and we've
Stage
seen
2
it just fall
propulsion
away.
nominal.
awesome. Everything is looking fantastic. Velocity is still climbing. That's great. So what I was going to say, we were seeing a view from kind of looking down the rocket like this, almost like the camera is up here and looking down at the cold gas thruster. That's what orients the booster. So
We've got some time before the next milestone, so let's take a look at the booster returning to Earth on the left of your screen. Everything's looking good there. A couple of minutes ago, the engines shut down on that first stage, and after the booster reached apogee, the reaction control system kicked in to reorient itself to place it on an ideal angle of attack for re-entry.
During re-entry, Electron will reach around 8 times the speed of sound on its descent, and the air around Electron will heat up to 2,400 degrees Celsius, generating an extremely hot plasma that creates a red-orange glow around the business end of the stage.
So you'll notice the booster is flattening out. It's still climbing because it had a lot of inertia. So it's basically coasting up. Eventually it'll hit zero vertical velocity and then be falling back down. So you're going to see this taper off, and it's going to just be a curve. I love that they have these trajectories up on screen. That is amazing. The second stage almost looks like it's overperforming, which is
That stage 1 booster is doing well on its way back to Earth, and stage 2 is making light work of its journey to orbit. You can see on the graphs there, stage 1 looks like just reached apogee and is starting its descent back to Earth, and stage 2 is well on its way. Electron's second stage moving at a speed of 11,000 kilometers an hour and just passing through 192 kilometers in altitude.
Yep, so about 145 kilometers peak altitude for stage 1. Just a little over, which is awesome. Stage 2 is still climbing, but the important thing is not necessarily just climbing, it's also mostly increasing its velocity. That's how you get it into orbit. That's actually the video I'm working on right now and almost done with, is comparing orbit versus space and kind of what those two terms are and why getting into orbit is such a big deal compared to just getting into space. We go through exactly all
Guidance
the
is
stuff.
nominal.
Apogee.
200 seconds remaining.
and all this fun stuff.
Back to the primary mission here, we're coming up to a milestone you'll see used only on Electron, the swap out of our batteries that our second stage Rutherford engine draws its energy from to run its electric pumps. The vehicle has run through the set of batteries we used for stage 2 ignition, so now we need to swap over to a fresh set to keep things going. We call this move the battery hot swap. We should hear that call come from Mission Control shortly, but keep an eye on your screen too, as you might just catch a glimpse of them falling away.
Yeah, you usually do. Got to see this box disappear. There it goes.
Hot swap successful.
And there goes the call for a successful battery hot swap. Listening out now for confirmation of the deployment of the drogue chute on stage 1. That'll bring the initial velocity of the booster down to about a third, from around Mach 1.4 to just Mach 0.5.
Now we're just hoping to see some data from the booster at some point here.
AFTS is safed.
So it turned off flight termination system. The automatic flight termination system. I don't know if that's on first stage or second stage. Likely first stage, actually, because second stage is still cruising along. But it's probably at the point, too, where if it did turn off, it'd burn up on re-entry, which would keep public safe. That's the whole purpose of the flight termination system, is keep the public safe if something were to be off nominal. So yeah, it's likely that we don't have telemetry from the booster as it's going through re-entry. There's a literal plasma trail that makes it really hard to communicate and really hard to transmit data through. So it's not unusual that we wouldn't have anything at this point. I know they're kind of hoping to at least be able to cover the booster recovery at some point. So we'll see if we get some footage of that.
Recovery vessel confirms drogue.
So they have confirmation of the drogue chute, it sounds like. That's great. That's the first of the 2 chutes.
And we're just confirming that we have just heard from Mission Control over the nets that we have had a nominal drogue chute deploy. This will demonstrate a significant reduction in velocity for our first stage ahead of the deployment of our much larger main parachute, which will take Electron to a soft splashdown in the Pacific Ocean, where our recovery vessel is awaiting to scoop it out of the water and begin that desalting process.
Stage 2 propulsion holding nominal.
Guidance is in terminal. 20 seconds remaining.
Stage 1 main chute deployed.
Ooh, good.
And confirmed on video.
Ooh, good. Hopefully we get to see that. They have the main parachute deployed.
And that's confirmation from the team in Mission Control. The stage 1 main chute has deployed and the booster is on about a 7-minute journey back down to the water. Meanwhile, in space, where that stage 2 is ferrying our customer spacecraft to their orbital destination, we're moving at a very brisk
SECO
28,000 kilometers an hour. And it looks like we've just had stage 2 shutdown.
Stage 3 separation confirmed.
Awesome work.
Nominal transfer orbit achieved.
That looked good.
And with that nozzle cooling and confirmation from Mission Control, we've had a successful second engine cutoff and kick stage separation. Today's satellites are headed to a sun-synchronous orbit, but as we mentioned before, our kick stage is on an elliptical first pass. It needs propulsion to course correct and orient it in the right trajectory for payload deployment, and that's where the Curie engine comes in. The first payload deployment sequence is scheduled for around 30 minutes from now, with a second scheduled for about an hour after that at T+1 hour and 40 minutes.
We won't have live video of payload deployment for this mission, but we will continue to follow along and listen out for those final few calls from Mission Control, as well as animated views of the end of the mission to visualize what happens in space when they do deploy. Before we take a break, we might want to have a bit of a check-in on the recovery again. I'm not sure if we've got that camera available, but I'm told that the recovery crew are patiently waiting for booster splashdown in the ocean. And once that booster is in the water, the crew will use their capture apparatus to grab the stage from the ocean and bring it aboard. If we get that recovery vessel camera back, we'll bring it to you as long as we have. But for now, we'll take a little bit of a break and we'll come back to you in a few minutes with confirmation of booster splashdown. We'll be back with you shortly.
Cool. Oh, and look, I don't have to worry about this music getting copyright striked because it's my own music. That's always fun. Thanks for using my music, Rocket Lab. You guys are awesome for more reasons than one. So yeah, okay, so just to kind of catch you up on everything, the upper stage is, and specifically the kick stage. So on top of the second stage, there's actually another little stage called a kick stage. And that is going to be coasting up to the highest point and circularizing the orbit to get it into its final sun-synchronous orbit. So that's what we're kind of waiting on now is it will do that. They said in about 30 minutes, it'll do the correction burn, which will get them into the circular orbit. Again, this is a topic that that you'll learn a lot about, hopefully, even if you know, I always hope that you learn something in my videos, no matter how big of an expert, but I dive into space versus orbit and all of the different things. We get pretty nerdy about the Kármán line. We get into orbital velocity, how you raise and lower in orbit, all sorts of things. This is kind of page one, or, you know, part one of a little bit bigger video that will come up after this, and that one I can't wait for because it's going to be awesome. So, just letting you know that's where we're at there. The booster looked like they had video telemetry and confirmation of it, as well as all the fact that the drogue chute went out, the main chute went out, everything was looking fantastic. That's what we love to hear. So, hopefully we are, I'm just gonna move this so you guys, yeah, okay. So hopefully everything is fantastic there. And hopefully they recover it safely and they get some, they like what they see when the booster is sitting in the water. So that's pretty much where we're at there. Yeah, what other questions you guys have? Looks like you have a lot of questions. We have a long time. I probably won't stream the whole time. I'll wait for good confirmation. And oh, and again, remember they're trying to get video back to us, but they are literally in the middle of the ocean, you know, a long ways away from infrastructure and things like that. I'll bet they're probably relying on Starlink to be able to transmit video data. Sometimes, you know, I know the pains all too well of trying to live stream, let alone live streaming in the middle of the ocean would be very hard. So I expect, you know, there can be so many little problems, encoders overheating or blah, blah, blah. The sync got out of blah, 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 and the, you know, the hoonie nanny and the SDI cable all of a sudden, you know. So I'm totally fine if we don't see any video. Doesn't matter to me. I know probably everyone is excited to see the recovery, but the important thing is the recovery itself, obviously. And look, there it says right there, now playing Cryo by Everyday Astronaut. I do know that guy. So let's see here. Hey, from Tom Brooks saying, I love your music, Tim. Thanks. You are also good at space stuff. Well, I appreciate that. Don't forget, guys, all my music is available on Spotify and wherever you guys listen to music. iTunes, all of the normal places you'll find my music. So that's always a fun way to, you know, I try to make music that's good for the background of things. If you're studying or playing video games or out on a run or a walk, and try to just kind of make chill background music. So yeah, if you're looking for something to listen to this summer, or I guess if you're in New Zealand this winter, yeah, check it out. Everyday Astronaut, you'll find it. It's free to listen, assuming you have all of the normal things in life. Okay, this is awesome from John Wolf. Thank you so much that it took me this long to get to this comment, but huge thank you for the huge tip. Thank you so much, John Wolf. Rocket Lab is my favorite space company. Please make live streams about them more often. Well, I'll tell you what, I try to stream because here's the deal. I think you guys know this by now. Historically, this is so funny. It's just so weird. Since the start of the channel, I've almost always done about a live stream a month. Give or take, you know, sometimes there'll be a 2-month gap if I'm busy. Sometimes I'm traveling or doing something that does not allow me to do a stream. I think the longest I've ever gone is maybe like a 3-month streak or something without streaming. No, probably not even that. We'll say on average about once a month, right? That's kind of always been the case. But now SpaceX is launching so often that it feels like I'm not streaming. People are like, why don't you stream anymore? I'm like, I've just been kind of doing the same thing I've always done, which is, you know, streaming about once a month, and specifically missions that I'm excited about. And I do try to get as many Rocket Lab streams as I can, just because they're, you know, less frequent. They're on average between 1 and 2 a month. And lately, for the last like 6 months, every time there was a stream, I had like some conflict, like my mom's birthday or something that was just like, I can't miss that to stream this, you know, and I really want to. So yeah, I'm glad that I was able to live stream a Rocket Lab launch. First time in a while. By the way, you guys should notice, sorry, I should have mentioned this. It might look like the rocket is actually going retrograde. And that is, in fact, because it kind of is. It's actually technically going slightly retrograde. Sun synchronous orbit is at like 97 degrees or something, so it's actually beyond straight south. It actually flies a little bit west, so it does actually have to counter the rotation of the Earth, which is also why it takes more energy, why you can't take as much payload to that spot as you could a more equatorial or a low inclination orbit. Yeah, let me keep looking here. Let's see, this is from Electronicnesis. I might have said that. I'm really glad that private space companies are springing up and innovating. It is an exciting time to be a spaceflight fan. There are so many rocket companies trying so many cool concepts. This is the type of stuff that, you know, I think at the early days of the space race, you saw everything just kind of tried and, you know, everything thrown at the wall. And I think we're just kind of back in that era now where, you know, things are being tried like this again. We're seeing a lot of new innovation, a lot of new ideas, a lot of shrinking of some things and embiggening in other things. Obviously, we have kind of the whole end of the spectrum here with between the Electron rocket being really, really small and compared to, you know, Starship, which is being worked on, and that's the largest rocket to ever fly. So right now in the, you know, throughout the world, there are rockets of all different shapes and sizes.
Splashdown of stage 1.
Doing, so I heard something about, oh, successful splashdown of stage 1, I think they just said. Which would be cool. I don't know if we'll get more of an update on that, so I'll keep it loud here just in case. Let's see. All right, well, let's keep going here. Thank you so much to Rhino for the... Oh.
For those of you just joining us there, we have had stage 1 splashdown in the Pacific Ocean. And you can see it on your screen just there. We're with the crew aboard the recovery vessel who will now be making their way to the splashdown location to collect their booster. As operations continue as normal, we will take a break again, and when we come back, we will share when the payloads are deployed. We'll be back with you at around T plus 46 minutes.
Cool. I'll just keep this up on screen because that's... Maybe we'll actually see them get out there and see the booster. That shot's cool. So that's the cradle, basically, that'll help pick up the booster. I'm actually a little curious how that'll exactly work. Like, is there a thing that slides underneath it or a strap that they... Maybe it's just a strap that goes... I don't know. I'll be excited to see that, though. I hope that they are able to stream as much of that as they possibly can. Let me know if music's too loud. I can't really tell. All right, let's keep going here. Sorry, again, I'm trying to just catch up. These are all from behind, and I'll get to the non-super chats. I'm just trying to kind of catch up on those as quickly as I can. So, thank you so much to Jonathan for Poutine Flyer. I'm not sure what that means, but thank you to, I guess, both of you. John Depker with 19 months of membership. Thank you, John. It's been a while since I've been able to watch a live stream from you. Got lucky today. Victorian says, hi, Tim. Well, thank you so much, John. Good to hear from you, and thank you so much for your 19 months of membership. And 48 months of membership from Rogue Flotilla. Finally caught a live stream. Been so busy with college classes. Thanks for all the video and coverage you do. Well, thank you so much for 4 years of membership. I didn't even know that. How long has YouTube? I didn't even think they had memberships that long. 4 years? That's incredible. Thank you so much. That deserves everyone in chat. If you can, just say thank you. Thank you. Let's see. Does Matthew Grundy asking, does Rocket Lab plan to reuse the entire booster or parts from the booster? They were testing a reusable engine not too long ago. That's correct. So I think they're just seeing what is viable. So they're just doing this kind of step by step. They made some tweaks to the booster. Now they're recovering it. They're going to see, how does this look? If things look good, you know, I would suspect they'll probably remove an engine, test fire the engine, make sure that it looks good. Maybe they'll remove all 9 engines, test all 9 engines, see if they look good. You know, fill the tanks, make sure everything, you know, looks like it's going to hold pressure and stuff. And then if things look good, they'll hopefully, you know, do a static fire test. And if that all looks good, and if they have no reason to fear that anything has been damaged and is inoperable, then they might go for it. Who knows? We don't know exactly what their plans are for this particular booster. So, but that is their goal, is to literally be able to splash it down, pick it up, kind of clean it out, purge it, fill it back up, and fly it. And We will see. They are, yeah, they are trying to refly an engine because they have talked about, you know, that they've retested it. They are planning to refly that engine. So, all just part of their, you know, testing campaign to make sure everything, you know, they cross all their T's and dot all their I's before they get into flying any customer payloads. So, yeah. This is a good question, Blake. How much refurbishment would you expect versus Falcon 9? I mean, I would expect that for now, with the unknowns of saltwater, they're going to be very careful in inspections and just making sure that everything's totally good to go. You know, obviously with the Falcon 9, there was a lot of worry about stresses of the fuselage, you know, as it landed. That was kind of one of the big things. Like, hey, this thing just kind of lands. Is everything okay from a structural standpoint? And again, how are the engines? We've never really looked at, besides the space shuttle engines, the SSMEs, the RS-25s, there really weren't opportunities to look at like the turbo pumps and look at all the bearings and seals and stuff of a orbital class rocket after it came back from space. So, you know, when they were first recovering the Falcon 9, there's just a lot of unknowns. And now I think they're getting to the point where I can't tell if the boat does kind of look like the boat might be turning, either that it's just a lot of weird compression artifacts making it look that way. But, you know, there's going to be, I'm guessing at least at first, there'll be a lot more testing than there is currently with Falcon 9. Because Falcon 9 nowadays is down to, you know, very, very little refurbishment and pretty quick turnarounds. I'm guessing this will be quite the process at first to feel good and confident about the sort of, you know, and develop a certification program to be able to refly the booster after it's, you know, splashed down. So, Johnny, sorry, so late that you probably saw. They do have video on board, and they try to stream it as much as they can. They've had really good luck sometimes streaming on board for a decent amount of the time. And sometimes they do also release it afterwards because a lot of times, you know, they'll record it locally as well. So we will see. This is what's kind of fun about the Electron. They actually don't even do a re-entry burn or an entry burn. They literally just let the booster fall back in and hit the atmosphere, and they built it in a way that it can handle the heat load. Has probably a little bit more. Well, here's the good thing about it being carbon composite is that it's lighter weight. At least the fuselage. I mean, fuselage is lighter weight, you know, compared to and likely less overall dense, at least per surface area, than the Falcon 9 maybe. You also have those heavy batteries though too, but you also don't have the extra propellant. So it's kind of like they found a way to be able to recover the booster and have it come back intact without having to do a re-entry burn. Actually, you know, the super heavy booster is planning to do the same thing. The super heavy booster is planning to not have to do an entry burn, just kind of, you know, take the heat load right on the base of the vehicle and just re-enter, just gritting your teeth. And that's what Electron's been doing with good success so far. Let's see here. Let's keep going on a few more questions. This is from Golan Heights. I have a good question. Is the technique permanently changed to water landing, or will they iterate to air capture and then land-based landing? So no land-based landing. There is no, there's no propulsive one. The Electron has the ability to run more or less completely dry, with very little residual propellant, and that's something that you normally don't want to do with a turbo pump powered rocket, because if it starts to starve, you know, especially the turbo pump and stuff, you can actually have explosions happen and detonations as your mixture ratio can get off in the main combustion chamber. If you start to have little, you know, gas bubbles and stuff. Electron, on the other hand, is the pumps are actually spun via an electric engine, or sorry, an electric motor. So, you know, if worst case scenario, if you start, you know, you still could have a bad mixture ratio potentially in the main combustion chamber, but the pumps don't rely on a mixture ratio. And worst case scenario, you can pretty much run the tanks more or less dry in Electron, or closer to it. And so there is no residual propellant at all left over in the booster. They run the booster all the way to depletion.
LDGC on range.
Sorry, they're saying something, but they stopped. I guess that's it. So yeah, they do not have plans and the capability. There's just no margins left over in this small sat launcher to be able to do a boost back burn or propulsive landing or anything like that. And they've also pretty much made it quite clear that they've given up on air recovery. Which to me, as soon as they got air recovery and then we're going to be putting it back on a ship, to me that just sounded really expensive to have both your marine asset and your air asset. At least when they were planning to maybe air recovery it and try to bring it all the way back to land, that at least kind of made sense to me, because then you're not having to have the marine asset. And Peter Beck told me in an interview that he hates the marine assets because they're very expensive. But at least if, it's better to only have to use one of those two assets versus both of them, right? So, yeah, I think that's kind of where they're at. Again, Gav, thank you so much. We don't know for sure what the fate of this booster is. Rocket Lab will have to inspect it, make sure everything looks good, and then they'll go from there before we know anything else, honestly. Yeah, I did catch us right at like T-minus 10 seconds. Thank you, Forge Gamer, for reminding me. Which is the splashy end? Actually, this is a legitimate question. So they do orient the booster to land engines first. So because of the power pack of the Rocket Lab Electron. Sorry, this is a Falcon 9. Those of you that obviously have been around probably know this is a Falcon 9. Pretend it's black or silver. Actually, I'm going to have an Electron over there, but it doesn't like come apart, and I don't want to remove it from the stand. But it does also have 9 engines. But the difference with the power pack of the Electron is there's a lot of batteries, lithium-ion batteries, heavy batteries, and then just, electric pump-fed rocket engines. And so they're trying to just keep the flamey end down, basically, but there's no flames coming out. But the good thing is all of this area is already pretty darn heat tolerant. Obviously, the engines have to be resistant. They're mostly Inconel. They can handle, I believe they're an Inconel alloy of some kind. They can handle very high heat loads. And they can handle that reentry stress, but also even the base of the rocket, around all the engines, there's kind of that flooring, and they've had to beef that up to be able to, make it so it can survive reentry. That's normally a spot that actually does, again, experience a decent amount of heat, because it does, the engines, when they're running, there's heat being developed down there, and so it already had to have some shielding. They just kind of beefed it up even more to be able to handle the reentry forces. But it is important that it maintains orientation, falling, engines first, which is why they do have, the little gas thrusters on Electron to keep it oriented through reentry to make sure those engines stay pointed engine first. So, yeah. Let's see. Any advantages coming from Southern Hemisphere launching? No. The only real advantage I can think of, as far as the physics go, no. There's the closer you are to the equator, the more potential you have to take Earth's rotation to your advantage. But when you're doing a sun synchronous orbit or a polar orbit or something like that, none of that stuff really matters as much. Actually, is there actually an advantage launching further away from the equator? I actually don't know. Anyway, to go back to that question, the one good thing is there's less air traffic. So, New Zealand obviously is not a very heavily populated area. There's not a ton of air traffic flowing through that airspace. So they have a lot less concerns with range control. Same with even boats and everything compared to, say, Florida. Florida, think about how much air traffic there is coming in and out of there between, especially even like Atlanta, Orlando, some of these major international airports are all kind of within the path of some of these places. Actually we have that map pulled up. So, flying from, through the Caribbean islands, you're going to fly right up that coast half the time, or from Europe going, to Orlando, you're going to be flying right through that path. There's a lot of planes. There's a lot of air traffic. New Zealand just does not have anywhere like it's 100th or 1,000th the amount of air traffic or something like that. So it's just a lot less considerations on launch day, and that's always a good thing. That's probably the only real practical advantage to launching in the Southern Hemisphere. This is from JM Studios. Saltwater exposure isn't the demon people say it is. Bad on electronics, but structures not so much. NASA did H1 saltwater immersion studies. Really? Refurb was 1/20th the cost of new. That's too bad they never ended up doing that on the Saturn 1B. That would have been really cool. Really cool. Yeah, there's certain things, if left unattended, where saltwater can be terrible to it. Just immediately rusting certain things out. But if you use the right parts, if you use, marine grade things, And especially if you wash them off and keep them flushed and or keep compartments sealed that should not be exposed to salt water. Yeah, I mean it's a thing you can do. It's a thing you can design around. Let's see here. This is from Merrick. Do I think Electron and Neutron will be the future of cheap satellite launches to orbit? I mean, I think right now Electron is filling a niche of things like this. Doing some demonstrations, putting up a couple, smaller CubeSats, small sats that need that dedicated ride, need to be able to get on the manifest quickly, relatively quickly, and get to their exact desired orbit. I think a lot of small sat launchers are trying to hang their hat on that exact thing, being like, hey, we can get you anywhere at any time. And so far, Electron is by far and away the best one at doing that, because they're the only ones flying regularly still. I mean, they started flying in 2017, and when they first launched, I was like, oh God, I hope they get at this, because there's a ton of competition right around the corner. And yet today, they're now the only ones standing, honestly, that are flying regularly. The Virgin Orbit was kind of the only other one that was actually flying semi-regularly, and they went bankrupt, and actually Rocket Lab ended up acquiring a lot of their assets. So, and hopefully a lot of those assets do help make Neutron cheaper and quicker, build it cheaper and quicker. Building a rocket, especially a large rocket, is never, actually any rocket, is never cheap and easy, and it's never on time. So anything to help aid in that process of being potentially cheaper, easier, more on time is...
Catalyst heater scheduled to enable.
Something about scheduling a heater to enable. But yeah, so I expect big things out of Neutron, even though it's not a huge rocket. It's frankly, it's about half the amount of performance out of it that you can get from a Falcon 9. Actually, if they fully expended it, it seems like it'll be on par with a Falcon 9 in reusable mode with drone ship landing. But yeah, I expect it. I don't know. Rocket Lab's one of the few companies. And this is hard to say because I'm a huge fan of all these ideas and all these startups, and I make personal connections to people. I just love the vision, I love the drive, I love the hard work and the work ethic of all these companies. But so far, Rocket Lab is one of the only ones that has really proven to fulfill and do these iterations and do great things. I mean, the boat has stopped, which has got to be a good sign, right? The boat has stopped. I'm gonna put that full screen. Yeah. Rocket Lab's one of the only ones that's really fulfilling a lot of things and constantly making improvements. They have so much spacecraft engineering, not just rockets, which I think is great. You can use that as a satellite bus now. Yeah, I don't know. I hope that Neutron works out great, because I think it kind of needs to at this point. I don't think you can survive long term with just launching the Electron. I don't think a lot of these small sat launchers are going to survive long term as just small sat launchers. I think you do have to step up into reusable rockets with medium launch lift capabilities. Let's see. Would a tail first splashdown damage the nozzles? Nope, those nozzles are pretty darn beefy. They obviously design, if you think about it, every, I'll say square inch, just because America, but it just sounds easier to me than saying square millimeter. But every square inch of that nozzle already handles a ridiculous amount of pressure. Obviously, that pressure gradient drops the further down into the nozzle you are, but the nozzles are actually pretty thick, pretty sturdy, and they already handle thrust of the, they already are capable of picking up that entire booster, basically, and pushing, more or less those nozzles in the combustion chamber is not only taking the whole weight and mass of the booster as it's accelerating, but it's also taking, times 1.5 to 3 Gs of force through the, well, actually it's the same amount of force no matter what. But anyway, the point is, it's taking all of that force already. And then as it hits the water, it's, experiencing hopefully a lot less of that because it's going slowly because of the parachute. So yeah, it must be getting really close. What does the Q stand for in max Q? It's pressure. It's, Q is the short, whatever you want to say, the shorthand for pressure. So maximum aerodynamic pressure, maximum pressure, because obviously if you're ascending, that's maybe something, I don't know if I should bring that up in this video that we're working on, kind of in the same realm. But yeah, max Q, basically, you know, if you think about it, if say you're at sea level and you're speeding up in a car or a motorcycle or something, and as you speed up, you obviously feel the air pressure getting greater and greater. Obviously, in a rocket, as you're speeding up, the air pressure is going to get greater and greater. But you're also ascending, so you're getting into thinner and thinner atmosphere. So obviously, at some point, there's a crossover where you're going faster and faster, but the atmosphere is getting thinner and thinner. So eventually, it actually gets to the point where the atmosphere is thinner and it's actually reducing the pressure on the rocket. And obviously, at some point, you're flying in space and there's virtually no atmosphere at all. Like 100, we measured it for this video. At 100 kilometers, you're at 0.00007% of atmosphere. So yeah, I mean, basically zero. Obviously, with a lot of extra zeros, you do have some trace amounts of atmosphere, but it's virtually zero atmosphere. The higher you get, the thinner that gets too, by the way. So by medium Earth orbit, there's quite literally zero, basically. Anyway, what were we saying? Yeah, max Q. So as you're ascending, the atmosphere gets thinner. The pressure on the vehicle gets lower too, even though it's speeding up. Let's see, from Mongoose 1616. Good job getting your music on this feed. You've come so far. Keep it up. Thank you so much. Yeah. Oh yeah. There's the booster floating nicely. You'll notice that the inner stage, the red part, is slightly tilted up out of the water. Again, because that's the lightest weight. Maybe we'll hear from them. That's the lightest weight, and the engines and the batteries down here, the thrust structure, or the thrust component, what do they call it again? Power pack is one way to call it, is going to be heavier. So you can tell it's just kind of floating in there a little bit bottom heavy, because it's a little bit bottom heavy. And again, they've hopefully designed it to be able to handle that. Look at how it's relatively calm water. Hopefully this recovery is nice and easy for them. Looks like they're already turning around on it. So we'll lose it out of the camera angle here shortly, but then next time we see it, I'll bet we see it kind of coming up from the bottom here, lining up with the carriage there. And I hope we get to see how that carriage actually works. That's gonna be really cool. From Edmund, keep YouTube great so folks like Tim can keep educating us. Thank you so much, Edmund. Yeah, I still love YouTube. I know I actually complained about it a little bit earlier today on Twitter about how shorts are just absurd. You know, we have a video with 1.7 million views on shorts, and it's made $58, and the views are going up, the money is staying the same, so they're actually making less and less money, which is weird. And it's, yeah, obviously it's not always about money, but at the same time, if you want to be able to create content for a living and, you know, have a team around you of people, it does require resources. And whoa, there's something. I feel like something's pushing the air. They must have a drone or something. Or is there a helicopter? Do you see the waves look like they're getting pushed out right there? Maybe that's just a artifact of the fisheye lens or something. Maybe that's just waves. Yeah, that might just be waves. For some reason, it looked to me almost like there is, rotor wash or something from a helicopter. But I think it's just me being silly. The Space Peacock, what was that awesome song? Yeah, again, if you're hearing any music in the background, that is original music. Let's see here. This is from Bait. If you spiral the injectors in a Bell rocket engine and imitate an arc rocket engine, would it work or cause a lot of cavitation? I actually am not even familiar with what an arc rocket engine is. Discord, am I missing something? What's an arc rocket engine? I'm gonna just look it up because now you got me curious to see if I even know what we're talking about. Arc jet thruster, electrically powered spacecraft, typically hydrazine or ammonia. Interesting. Yeah, it's yeah, I'm not actually familiar. I'd have to read up on, I don't even know enough. I literally don't even know what this is. So I'm not going to answer and act like I know anything about it. So, I have no idea, and I'm sorry to disappoint you. Let's see here. But thank you for the question and the super chat. Jacob Free, why do rockets throttle down for max Q? Well, there's a few reasons. Number one, it helps reduce the structural load on the rocket. So you can have a trade-off. It might be, at the end of the day, it might be easier to make a rocket, hit a certain target of mass and weight, and keep it at a certain, you'll just say, hey, here's how much structural load we can take on this rocket. We have to keep it under that. So we actually know on ascent, we have to just keep it at this point, and they'll actually throttle down to keep it there. And it might actually be higher performing to do that, and to be able to get through that thickest part of the atmosphere. But it's also, again, kind of for that same reason, if you're just punching through the atmosphere, you might end up fighting more and more and more drag. And there's a chance that most of the time it's actually more efficient to throttle down at the point where the drag is the greatest, just so you're not wasting a bunch of propellant just simply fighting drag. You know what I mean? Just pushing against the drag. If it's not really getting you anywhere, you know what I mean? If you're not continually accelerating. So say you're putting in twice as much thrust, are you accelerating twice as fast? No, like at maximum aerodynamic pressure, increasing thrust twice as much might only give you like a tiny bit of extra thrust in the grand scheme of things. Kind of like a airplane. Have you ever seen like there's a drag and then there's thrust, and those two things, as you're cruising are equal, whatever. Yeah, kind of like that. What did I think of the steel plate test today? That was cool. It looked like my understanding is it might have just been like a purge. I don't think that was still the full. We haven't seen the full beans on it yet, but yeah, that's cool. I'm excited to see how that works. My big concern though, I'm sure they've thought about this, and I'm sure there's a way to. I'm worried like all the sand that's around there. Everything gets covered in sand out there. Everything. It's everywhere. It's literally everywhere. How are they going to keep that from just totally falling down into the shower head? And like just building up sand all over the place? Are they gonna have a cover over it when it's just sitting there? I would kind of assume so. Wouldn't you? Oh, sorry. Juan in Discord reminds me of something very important. The Q in max Q is actually dynamic pressure because P is already pressure. So pressure total. So dynamic pressure is Q. Good call. Boom. Thank you, Juan. Let's see here. So this Dicey Dino, I know the rocket was launched from New Zealand and not Virginia, but why does Rocket Lab launch from Virginia instead of Florida? Is it because of the size of the launch pad? So I'm guessing stuff like this comes down to the cost of everything, and I'm guessing that Virginia and Wallops was more eager to lease out a launch pad, give maybe better tax incentives, give a better deal on land and operations over operating from Florida, because Florida is actually getting to the point of being like relatively, it's a busy spaceport these days. So you'd have more traffic. You have, well, I don't know about more air traffic, but you just have more launch opportunities to interfere with launching. So Virginia, you kind of get more of the run of the show as opposed to Florida. So I'm guessing between potential costs overall and plus the availability of the launch sites, I'm just kind of guessing. That's why, but I don't know for sure. So from XX Abiana XO, I don't know. But yeah, it says after 4 months of membership, thank you so much. Can we get a sneak peek of what 100 scale model is next? Yeah, so we are actually working on, so Falcon 9, obviously very prolific rocket launcher today. First one to fly humans since the space shuttle. But I decided that the next one we're going to do, and this might be not something that everyone thinks they want, but I think it's really cool. We're actually going back to the beginning of American spaceflight history. So we're actually going to compare, it's going to be a 2-pack for this, which would be both of the Mercury launchers. So Mercury Redstone and Mercury Atlas, which are honestly still some of the most iconic rockets. But what I'm excited about is I really want to be able to see those at the same scale to the Falcon 9. Like literally the upper stage of the Falcon 9 with the Dragon capsule, I think is going to be bigger than the entire Mercury Redstone rocket. So it's going to be really fun to see them.
Welcome back to the webcast of Rocket Lab's 39th Electron launch. We are now T plus 44 minutes into the Baby Comeback mission, with the first of 2 payload deployment sequences coming up shortly. Before that though, let's recap on the mission so far.
Baby Comeback launched at the top of the window, lifting off the pad at Rocket Lab Launch Complex 1 at 1:27 New Zealand time or 01:27 UTC. Electron had a clean pass through max Q, main engine cutoff, first and second stage separation, and then second engine cutoff, followed by final stage separation from the kick stage carrying today's satellites. While that happened, the first stage began its descent back down to Earth under a parachute and has since successfully splashed down in the ocean. And while we were on our break, you would have seen that recovery vessel approaching the splashdown booster.
The kick stage is now coming up on payload deployment shortly. First, the Curie engine will ignite to position the kick stage in a circular orbit ahead of its mark. Then the NASA Starling satellites will deploy one at a time, followed by the Spire satellites. The Curie engine will then ignite again, making an inclination shift ahead of the deployment of LEO 3 for SFL and Telesat. That second deployment sequence will be taking place in about an hour or so, and we'll update you as it happens. Meanwhile, we're listening out to Mission Control for confirmation of that first of 4 Curie engine burns.
Cool. Yes, the Falcon
Curie
9.
ignition confirmed.
Ignition of the engine confirmed on the kick stage. That's awesome. Yes, the Falcon 9, as it re-enters, will have a lot of plasma, and actually, especially like faster.
And that's
missions.
Mission Control reporting a successful Curie engine ignition. This burn will last for around 120 seconds before shutting off, shortly followed by the start of our payload deployment sequence.
So yeah, the what was I saying? Yeah, watch any of the especially at night, you see it like crazy. But even the fairings create a lot of plasma on reentry. SpaceX has released some videos from the fairings where you see plasma, and they're going. They're actually going a little bit faster than the booster, just a little bit. But the booster is a lot more dense, has a lot smaller surface to area ratio, or weight to mass to surface ratio. There we go. And so sometimes, especially on like geostationary orbit missions or ones where they're pushing the booster a lot further, it makes a crazy amount of plasma, and you just really can see it, especially at night. On some of the lower energy missions, if they're doing a return to launch site, I'm sure there's some plasma buildup. I don't know if it's as prominent. Actually, I don't know if there is plasma buildup on those ones, but the velocities are a lot lower. I don't even know what that. Let's see here. Thank you so much to all of these people with the great questions. And Wayne Fox, I appreciate it. Oh, the rocket engine you were asking about in your last question, the arc engine is an aerospike. Now that I didn't know. Sorry about that, Bait 215. So the injectors, typically, injectors shouldn't put, even swirl injectors. Was that the question about swirl injectors? Let me see here. If you spiral the injectors in a Bell rocket engine and imitate an arc rocket engine, would it work or cause a lot of cavitation?
Curie engine cutoff confirmed.
Apogee is 576 kilometers, perigee is 574 kilometers, and inclination is 99.45 degrees.
Fantastic news there from Mission Control. Curie has shut down at the expected altitude. We have about 25 to 30 seconds now until that first deployment for NASA.
Cool. That's great news. Bait, again, sorry, I don't quite understand.
Payload deployment confirmed for NASA Star.
So again, obviously, we're just seeing animations of these. But yeah, that's the second one deploying successfully. Great to hear. This is from Zimri says, would you do live streaming again for Firefly? It has absolutely nothing to do with Firefly. Absolutely would in a heartbeat for Firefly again, as far as a customer. Starlink 3 has just been deployed, they said. But I just can't handle, honestly, it was just way too much work. And it turned us into a production company, like a live stream production company. And it took away from all the other things that I wanted to do last summer for making videos. You'll notice, obviously, there's a big lull in videos in the channel during last summer's streak of trying to do major launches. And obviously, Firefly was one of them, and so was Artemis. And I'm just trying to kind of calm down on that stuff so I can just work on what I enjoy. And that was just too much stress. And yeah, it's just, it was just, didn't always work. I'm just such a perfectionist that when things aren't perfect, and live streaming is rarely perfect, it's just too easy to be disappointed. So, oh, there we go. Another, that's, I think, I'll try to keep this a little bit louder.
Deployment confirmed for Spire 1.
Fantastic news there from Mission Control. Payload deployment confirmed for Spire 1. We have the last 3U CubeSat for Spire coming up shortly, and then we'll have another coast phase briefly, followed by the SFL deployment at about T plus 1 hour 45.
Cool. But anyway, yeah, I'm really trying to cut down on the traveling live stream stuff, because it's just, okay, Spire 2 just payload confirmed, so we're good to go there. And just focus more on the videos. There's a ton of videos that we're working on, and a ton of things that I'm trying to get done this year. Just as things start to ramp up and get crazy, you know, it's gonna get really, really crazy with Starship launches, I'm sure, at some point. Just trying to make it so it's sustainable and fun, and that I'm getting the work done that I want to be getting done. The video that like I said, the video we're working on right now, so there's another like 50 minutes until the next payload. So this will be my sign out then. I'm not going to wait for the last payload deployment. Sorry. But yeah, the moral of the story is that I'm really excited about the video we're working on. It has a ton of animations, and I love, like, the animations are so fun to make, and I think they're so valuable to have good visuals to some of the physics and some of the things that we talk about in these videos. So I'm really excited about the videos that I'm working on right now. The long list of them. There's some ones that I think you guys are going to really, really, really like that are a little extra special. And yeah, and all those live streams, traveling and stuff, just takes up so much more time than what it seems. Even to the point, you know, of, let's say I travel and have to go somewhere for a week, you know, like with Firefly or Artemis or something. Just the exhaustion, you know, sometimes we'll be running on almost no sleep. By the time I get home, like, I'm just wiped out for like 2 days and have zero energy to, you know, and desire to keep working. So it's always more than the sum. And oftentimes, like, leading up to that, it's like, oh, we're doing a ton of work to prepare for this. And that's taking away from the things that I want to be doing. So I'm just trying to be better about saying no, even though some of the opportunities are really fun. I mean, Firefly, it was really fun, actually. It was really cool to be able to be there and get on base and see all the cool stuff and talk to so many awesome people, meet amazing people. And then to see the first successful launch was awesome. I definitely don't regret it, but it's just so much extra work behind the scenes. And it just, like I said, just took away from everything else. So I don't want to, yeah, maybe I'll start a separate company that I don't have anything to do with, or something that just takes the van and drives it across the country and does live streams, and I don't have to worry about it or something. I don't know. But yeah, that's kind of that. Other than that, let's see. This is from David Ryle. Great question. When the satellites are released sideways, how does that affect the orbit? So the rocket, you know, the payloads at this point are traveling at roughly 7 kilometers per second. So, you know, roughly 17,000 miles an hour, 28,000 kilometers an hour. Very, very, very fast, right? And those are being ejected at 10 meters per second. So, you know, 20 mile an hour, 30 kilometers per second, or 30 kilometers an hour, like a teeny, itty bitty tiny fraction of the velocity compared to how fast they're going in one direction. So that has a very absolute minimal amount of change in velocity that can easily be compensated by most satellites, you know, if it really mattered. And most of the time, that's well within the margins of what's a normal, you know, for the orbit. And so many times, the little satellites will do small adjustments anyway, just to, if it's that important to be at an exact spot, especially geostationary orbit, you know, you really need to be staying within a certain spot. And so it does need to be precise, but a little tiny push like that is absolutely nothing in the grand scheme of things. So, yeah. Well, I think that's gonna do it for me. So hopefully, again, I hope that you guys enjoyed today's launch, and congratulations so far. Again, don't want to cut it out too early, but I'm not gonna stick around for the extra hour here, basically, to see the last payload deploy. But thank you to all of you guys who stuck around, and it's been awesome. And yeah, you guys are fantastic. again, I'm gonna go right back to work now to try to finish up. We're working on this video about orbit versus space, and just trying to get that out here before Thursday, because I'm gonna be gone for a decent amount of time here, and would love to get it done before then. Would love to get it out before then. So pushing really hard to get that video done. So wish us luck. It's relatively long, not long in the terms of normal things, but it has a ton of animations, but they're gonna be great. So I hope you guys enjoy that. So that being said, thank you all for watching. I really appreciate it. It was fun doing another live stream again. Congratulations to Rocket Lab. I can't wait to see images of the recovery of the booster. Can't wait to hear how it came back. And congratulations to NASA, Spire, and SFL, or whatever their initials were. I already forgot the initials of them. I should probably look just so I'm not signing off to nothing of the right thing. It was SFL, yeah, Spaceflight Laboratory, that's right. So congratulations to all of you guys on a flawless looking mission, and I can't wait to hear how the rest of it goes. So thank you all so much for tuning in, hanging out with me tonight. It really means a lot. So hopefully we'll see you guys again in the near future. But for now, that's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody.